Uh, Good morning, everybody, and thank you, Thomas, for the introduction, and I want to thank the organizers of Strata for inviting me to come speak today. So the subject of my talk is, what does your smart car know about you? And what this is I'm going to speak about kind of the data that is gathered by connected vehicles and what can be done with that data. So first off, can't have it do anything without the lawyer's interjection. Oh, by the way, I work for Booz Allen Hamilton, and we recently started a small cybersecurity research group called Dark Labs, and that's why my slides say Dark Labs instead of Booz Allen Hamilton, but still part of the same company. So in any event, so that's the lawyers say. Okay, all right, now that that's out of the way. Okay, so I wanted to kind of give a little bit of background. One of my research interests is connected devices and kind of just what a lot of people focus on IoT and in terms of like security, but I haven't seen a whole lot of discussion about kind of like what data these things are gathering and what can be done with that data, both for good and for perhaps nefarious purposes. I did a presentation at Strata in New York where I looked at home automation devices, and basically the premise was that you could reconstruct someone's life based off of the data that was gathered from home automation devices. And so in essence, these devices really do gather a monumental amount of data about an individual, and they don't. What makes it kind of interesting is that they don't really store the data locally, but when they transmit it to cloud servers, and so you can do the analysis on it. So I wanted to kind of also say just a little bit why cars, and so I'm a bit of a gearhead. I'm currently fixing an old British sports car, but I read an article. What really got me interested in this subject was I read an article. I live in Baltimore, first of all, and in Baltimore we have two things which there was an interesting convergence, and one of the things we are known for is crime. I don't know if the show The Wire has made it over here or not, but if not, it's a unfortunately fairly accurate presentation of parts of our city. But the other thing that Baltimore has a lot of are cybersecurity researchers. And those two worlds, there was an interesting convergence of those two worlds when a cybersecurity researcher's vehicle was stolen and recovered. And the victim, I guess, he wanted to see if he could figure out who stole the vehicle because the police sure as heck weren't going to do it. And so he started looking at the data that was contained within his car. And it turned out that the thieves left a trail of data that he was able to use to ultimately find their Facebook profiles, and which he then handed over to the police, and they were able to arrest the suspects. So I read that, and I just started to think that's really interesting, and just kind of what else can you do with data that cars that comes from vehicles? So again, I would say that most people really don't think of cars and of just Internet of Things devices, like if you buy a smart thermostat or a smart light switch or something like this. People don't really believe that these, or sense that these things are actually data gathering sensors, but they are. And ultimately, again, this data can reveal a lot about people, and most people don't even realize that it's doing it. In my last presentation where I spoke about this, the most egregious example that I found of this was this thing, which is a propane scale, and what it's supposed to do is if you put this under the propane tank in a grill, it measures how much propane is in there and sends you an alert if you're running low on propane so that you don't run out amidst grilling. In looking at the data that this thing was actually gathering, though, I discovered that it was broadcasting the latitude and longitude of my house. That isn't my house, but I couldn't help but wonder, why does a propane scale, A, need to know where I live, but B, why is it broadcasting that, back to some third party? And so, again, I just find this stuff interesting, and there's a lot of different things you can do with it. So when you start collecting all this data and aggregating it, it can be extremely revealing. And so just, again, I'll get to cars in a second, but if you consider just a light switch, if you have a dumb light switch, as it were, you turn on and off a light, and that's it. However, if you have a light switch that is connected to like a Wink hub or something else that's going to be broadcasting the fact that you turn off and on that light to some sort of server where that data is going to be stored for perpetuity. And if you give that switch a name, like, say, bedroom, now all of a sudden you can build out a pattern of activity against the owner, and you can figure out, well, this person turns the lights on in their bedroom at 7 o'clock in the evening every night, and turns them off at 10 o'clock, and then turns them on in the morning at such and such a time. And so you can build out a pattern of activity for the owner of that. And you can also do anomaly detection. So you could figure out, well, normally on Saturdays this person turns on their lights at such and such a time, but this morning it didn't happen. So there's something there. So in any event, what you can do is you could figure out things like, when is the person home? And this was some data that I put together from my Nest thermostat. And so what you could see here is this is just like, basically from this you could determine when is most likely that my house is not occupied. Now, when I speak to people who kind of aren't in the business, this is what I get. A lot of people I've spoken with just kind of say, well, these little toys are interesting and fun, but I don't have them. I don't plan on owning them. Why do I care what data these things are gathering? And so it doesn't really seem to have a lot of relevance. And so what really kind of, again, what occurred to me in doing all this was that most people aren't aware that after your smartphone, they already own one of the largest data collecting devices out there, and that is a car. So I'm just curious, how many people are there people in this room that are in the automotive industry? Okay, a few. All right. So I'm just curious, how many sensors do you think a basic car today has in it? 10? 20, maybe? 30? 30? Do I hear 30? 40? 40 in the back? 40? Anyone? 300? Okay, so a basic car today has between 60 and 100 sensors. There's no legally mandated standard. It just really depends on the vehicle. But that is a kind of a minimum for what I found. Now, a lot of these sensors can include things like oxygen sensors. You can read the list up there. But what you can see there is a lot of them are, the intent of them is to monitor the pollution control systems within the vehicle. And of that, would anyone care to take a guess on how many fields of data these sensors can record? Again, as a minimum. Yes? 5? 5? Okay.
Altogether?
Yeah, altogether. 1,000? Okay, that's closer. So the data that I was gathering was almost 600 fields of data every second. And so in the US, these kinds of onboard diagnostics are required by the Clean Air Act of 1990, or the amendments to it, rather. And it mandated that as of model year 1996, all vehicles had to have the onboard diagnostics that complied with a certain standard. And so it really has not changed since then. In Europe, there is a similar requirement that was introduced in European Directive 98/69/EC. It's known as the EODB standard, or European Onboard Diagnostic. And as of model year 2001 for cars that use gasoline and 2003 for diesel vehicles, all vehicles are required to have a similar setup of onboard diagnostics. Now, the way you access this may or may not look familiar to everybody, is there is a plug that looks like this that is generally located underneath the steering wheel or thereabouts. And you can, if your car's check engine light comes on, you can plug in a reader to this, and it will tell you the codes that are there. But the thing is that all this data that your car is gathering, it's stuck in your car, so it's not really terribly useful. And so this is where kind of we've had a convergence of technology in the last few years that I think makes this a really there opens up some really interesting possibilities. Now, one of the problems, though, with getting and analyzing this data is that a lot of it is not really documented all that well. And this was done deliberately. There was a lot of, as they call it, security by obscurity. And so the protocols are not necessarily documented all that well, or you have to pay a lot for the documentation. Again, the goal being to keep people from kind of meddling with this when they shouldn't. But in any event, the convergence so if you take a car and you add to it storage, GPS, and an internet connection, now all of a sudden you can get the data that this car is collecting off of the vehicle, transmit it to some sort of other server, and we're in business. So we can actually start analyzing this data. I should have mentioned also before that vehicles by themselves typically don't have a lot of storage in terms of like memory to keep this data. So they're gathering it, but they're not really keeping it for a long period of time. I assume it's some sort of like rolling buffer, similar to what like an airplane's black box, where it just records like the last few minutes or something like that. But the bottom line is, a vehicle itself is not actually storing every trip you make as you're going it forever. So for this experiment, again, what I was trying to do was I wanted to kind of show what I could learn about a subject, in this case myself, from the data that I was able to extract from my car. So, not really. So I wanted to first off kind of just talk about how we actually extract the data from this, because this kind of is somewhat important. So I use this device called the automatic car dongle, and I'm just curious, how many people have heard of this? Okay. Unfortunately, I don't think this is available in Europe. I guess the communication protocols for vehicles must be a little bit different here than in the US, but I mean, even though the plugs are physically the same. But in any event, what this device does is, so you connect this device to the onboard diagnostic port to your car, and this is what they claim that it does. So they claim that it will put your car's data to work. You can decode the check engine light. It will give you real-time alerts. So if you slam on the brakes or if you're going really fast, it will tell you that and tell you to slow down. In theory, they claim that it's to help you improve your driving, and they have some kind of neat features as well, where if you have like a teenager driving, you can set it up so that it will like send you alerts if they're driving recklessly or crashing into things or things like that. So they also have a dashboard online where you can monitor your trips and look at things like that. It's kind of neat. And it's at automatic.com if you want to have a look at it. What got me interested in it, though, was that this device interacts, or is capable of interacting with other Internet of Things devices. And so in particular, the Nest thermostat, are you guys familiar with the Nest thermostat? Yes, no? Okay. If you're not familiar with it, the Nest thermostat, it's a thermostat that uses machine learning to kind of learn when you're home and when you're not. And so it will program itself to kind of optimize your heating and cooling usage. And so what was advertised with the automatic one, this is why I bought it in the first place, was that you could set it so that when you leave your home, it would shut off your heating and cooling, and then when you get within a certain radius, it will either preheat or pre-cool your home. And I thought that was kind of neat, and just generally, I wanted to see what you could do with that. Unfortunately, it didn't really work all that well for that purpose, but that was why I got it in the first place. It also interacts with if this, then that, and I'm just curious, as a show of hands, how many people have heard of this service? Okay, slightly more. Okay, cool. And a third one that it works with is Concur. Is that another service that is US only? Okay, all right, so what Concur is it's a service for businesses that does expense reporting. And so if you use your vehicle for business purposes, what the automatic will allow you to do is it will allow you to import trips into Concur so you can get reimbursed for mileage. So again, not that it's a terribly difficult task to do that by yourself, but I thought it was kind of interesting that you could do that. In any event, as I mentioned before, what what I was interested in was how this could talk to the thermostat. In theory, it seemed like it was a great idea, but in practice, it did not work very well, largely because of the security protocols that the Nest imposes rather than on the other way around. So the way the Automatic actually works is it's a Bluetooth device that communicates with a cell phone, and it transmits data that it's gathering from your car's onboard diagnostics to the phone, which then in turn uses the phone's 4G or LTE connection to send it to the Automatic servers. Now, this is all fine and good, but how do you actually get at this data to do something kind of cool with it? Well, my original thought was I wanted to see what you could do here to see if you could maybe sniff the Bluetooth and analyze that data, but after I kind of thought about it, and that didn't seem like such a wise idea to try to be driving around with, sniffing Bluetooth with a laptop open. So instead, I opted to look at it here. And this turned out in practice to be a lot easier. So Automatic provides an API, which the documentation is available here. And I'll put these slides online when we're done. But so you can look it up here, and you can see kind of what data they will expose via their API and they provide some example scripts in PHP, Ruby, and Python, so you can kind of play with that data. Now, this API is protected by Open Authentication 2, and if you want to access it, you do have to request a key from Automatic, and you have to give them some reason why you're doing it. And there also are, of course, terms of service, and there's an end-user agreement which you have to agree to, and data handling protocols and so forth. So there's that. And there's also this library which someone wrote that I found that it kind of simplifies connecting to it and so forth. So if you want to play with this on your own, you can use that. Now, okay, so let's actually look at the data. So with this, if you kind of query their API, this is the most basic kind of data that you can pull out from this. And what you can see here, there's a few things I would like to draw your attention to. The first is this. So the VIN stands for Vehicle Identification Number, and this number uniquely identifies the vehicle. If you have this information, in the US, there's a number of services. There's one called Carfax where you can actually put in the vehicle identification number, and you can get a complete vehicle history from that. You can also look up, there's some other services where you can look up like license plates and registered owners of vehicles based off of if you have the VIN, which in retrospect really doesn't seem like a good idea, because in the US, it's mandated that the VIN is like kind of on the... It's visible from the outside of the car, so theoretically you could just walk around a parking lot and take pictures of that. Anyway, okay, off subject. Now, you can also see the make and model of the vehicle, as well as the year, the submodel if it's there, and what color it is. And you could see the fuel level, and then when this was actually added to the Automatic account. Now, this doesn't seem all that interesting, but if you were to write a script, which I did, and query and ping this, like every day or so, you could monitor things like changes in the fuel level as well as changes to vehicles. And so what we can learn from this is that we can learn that basically what kind of car I have, and you could also get the complete vehicle history, and you would also learn that I have another car that's on this account, and you would see that a Hyundai Santa Fe was replaced in May with a minivan. And there was much depression shortly thereafter. Okay, so this gets us basic information about the vehicle. Somewhat interesting, but not really, because you could walk by my house and get the same information. So let's look at something that's a little bit more interesting. And this is where this service comes in. IFTTT stands for if this, then that. And this is a really neat service. And if you haven't played with it, I would definitely encourage you, even if you're not into like IoT stuff. What it does is it lets you have something happen if something else happens. So for instance, if you get an email from Twitter, say, you can set up a response that emails the person and says, thank you for following me. It also will talk to a lot of IoT devices, so you can say things like, if I enter a certain radius, turn on my lights. And so there's all different sorts of things about with if. I don't know how you actually say this, but I'm just going to call it IFTY for the remainder of the presentation. So there's a lot of different things that you can do with this that make it pretty useful. IFTY refers to the different components that it can connect as, I think, it refers to it has recipes, which is the actual action that happens, and then they call them channels for the actual devices which you can interconnect. And so there is an automatic channel which allows you to do things upon actions that happen with the automatic. And so since there is a Google Drive channel and an automatic channel, what you can do is every time the automatic denotes that a trip is complete, in other words, you shut off the car, it will then send the data to a spreadsheet, and now you've built a tracking device, which can record metadata about every trip that you've made. Now, I mentioned before so this data is actually available as well in the automatic API, but it's a little bit harder to get at. And what I found was interesting and somewhat a little scary here was that IFTY was only protected by your username and password, as is access to the automatic account. So ultimately what this does is this has the effect of bypassing the open authentication to protections for your data, because you can get it all of the data, if not a little bit more, via IFTY. And so what this data contains, this is a little bit more interesting in terms of kind of finding out interesting stuff about a person. So you get, among other things in this spreadsheet that you build out, you get trip start and stop times, you get latitude and longitude for the start and the stop positions, you get the path that the vehicle actually took, you get the duration, you get some indications of speed. There's a few little things. Again, automatic, they're trying to help people drive better, so they'll tell you how many times you slam on the brakes, how many times you drive over 70 miles an hour, and it also tells you what vehicle that is in use there. So you can pull this information off of the automatic dashboard, but that's a manual process, and so this can be completely automated. And again, it's just as you're driving, every time you get in and out of your car, it's recording that information to a Google Drive or Dropbox or whatever FTP server you might have. And so with this, now you can really kind of get into a target's pattern of life, and you can figure out a lot of information about the person. So just I'm going to show you just kind of a high-level overview of some of this stuff, and I'm not going to get into too many details just because I'd like to maintain some privacy, but this is a chart of just number of trips per day. And so you can see here there's a kind of a normal distribution of this on every day of the week, except for Saturday. There's a glaring thing right here where you see that there's virtually no activity on Saturday, and then Sunday kind of kicks back up to a relatively normal level for me. So, this is not trips per day. This is just total trips, rather. Why? Why is this the case? Well, as you probably noticed, I'm Jewish and I'm Orthodox, and I keep the Sabbath and don't drive on Saturday. So what this means is that if you are automatic now and you are looking at a profile of all of the users who use this product, you could now identify other individuals, if you knew this pattern, who are also Orthodox and Jewish and therefore don't drive on Saturdays. Or you could just find people who don't drive on Saturdays. But in any event, you could do that. Now, let's dive into this a little bit more, and let's just look at this is a breakdown of trips per hour per day. And so if you look down here at the bottom, you can see a counter, that's the hour of the day, and just kind of watch what happens. See, around 4 o'clock, typically go home. Wednesday. Oh. So watch this. So now there's probably a lot of things that you could figure out from this, but I just wanted to kind of, the fact that there were seemingly a lot more trips late in the evening on Thursdays caught my eye, and I decided to kind of look at, well, let's see what we can figure out from that. So in addition to just the times, we also know kind of where the person is going, starting from and going. And so if you looked at the data that was collected from on Thursdays after 7 o'clock in the evening, what you find is that these two addresses were the most common. Now, you don't get addresses out of the automatic. You get latitude and longitude. So you have to use a reverse geoencoder or decoder, whatever you want to say, to actually get street addresses. And so this is a little bit tricky because what if depending on if you park the vehicle, where exactly you park it, you get slight variances in the latitude and longitude. So you have to kind of truncate the lats you have to kind of round it off a little bit to just get a little bit more consistent results there. But in any event, these were the most common addresses after my home and work during that time frame. And so what you did, if you plug that into a Google, what you find is that the first one there is, or the second, this is the Smith Avenue address, and this is the Reisterstown Road address. And what you find is that these are the nearest grocery stores to my house. So what does this mean? This means you've now determined that the most common time when I go grocery shopping are Thursday nights late at night. Now, this is a kind of trivial example, but what you could see also if you were to look at it from the other perspective, you could see when does a person typically go when are they likely to be at a particular location, or when are they more or least likely to be at a particular location, and you could start figuring out those kinds of patterns. Again, if you were in Automatic's position and you were looking at all of this data across all of their users, you could provide stores with demographic information. For example, you could look at an area around a store and you could say, well, 60% of the vehicles that park in your parking lot are BMWs and Mercedes. So that might reflect something about the demographics of the people that shop at that venue. And you could there's probably a lot of different things that you could do with that kind of information if you have all of it versus just one individual. Okay, now you can also map out exact trip patterns from this data. So interestingly enough, as part of the data that you can pull out of Automatic via the IFTY device, you can get a map of these paths like this. And so what you can do with this is this is a map of my commute to and from work, and you can see that this one right here is a little bit different. So again, you could do some change detection on this, and you could see, okay, well, we know that these trips began and ended in the same location, but the route is different. Why? And it could provide some interesting insight. In this case, most likely there was traffic on the Beltway, but in any event. Okay, now one of the fields that we were pulling back from this is the path field. And when I saw this, I knew this had to be good, right? I mean, this just jumps out as everybody as being something useful, right? Okay. So what this actually is this is called a polyline. It's a polyline format, and it's a format for Google for encoding arrays of latitudes and longitudes. And so if this is Python code to actually decode it into a Python list. I'm sure there's like R or Ruby libraries that do the same. There's online APIs that can do it for you. But what that will get you is an actual array of geocoordinates, which if you were to map this out, you can see exactly where this is. And so you can follow the exact path for this trip. And so now, not only do you know the beginning and end points of a trip, you also know exactly where I was at any given time along the way. Now, this is all fine and good. This is all kind of like what I would say is just kind of metadata about the trips. What I was really interested, though, in doing was trying to use some of this data that was coming out of the car. Again, there's all this data, the 600 columns of data per second. What can we do with that? And while I'm sure there's a lot, so let me actually back up a step. So some of this data, what I was really interested in were the sensors that actually have something to do with how the driver is interacting with the vehicle. And so the sensors that were of particular interest to me were the accelerator position, the gear shift indications, the engine speed, the vehicle speed, and some vehicles have a clutch and brakes position, and then the accelerometer. All of these sensors right there can give you a sense of how the person actually drives. And so what I wanted to do was I wanted to see if you could uniquely identify a driver based off of the data that was gathered with how they're actually interacting with the car. In other words, kind of fingerprint a driver based on how they interact with the car. And so I was sort of able to do this. I had a lot, I gathered several months worth of data, started analyzing it only to discover that I had a significant portion of corrupted data that was missing columns or just otherwise corrupted. And so I wasn't able to really definitively say that you can do this, but I'm reasonably sure that you can, and I'm going to show you what I got, and I'm actually going to continue working on this and try. I was speaking with another presenter, and we came up with an interesting idea of how to actually gather more data so that we can definitively do this. But what you're looking at here is this is a chart. This represents 500 seconds of activity, and this is the engine speed when the vehicle was in second gear of one driver. So the blue line is the engine speed, and the green line down here is accelerometer data. And so what that represents would be like, is the person, are they really stepping on the gas and throwing you back in the seat and then slamming on the brakes, and are they very jerky driver, or is it a very smooth transition? So this is driver number one, let's call them. And here's driver number two. And so what you see here is that driver two here, first off, there's a much bigger range from the shift point. So you see here, this is idle in the car is about 700 RPM, and the red line is, I think, 6,500. But you can see that there's a much bigger range. Let me just go back a slide here, where this driver doesn't really take advantage of much of the range of the engine. They kind of, the minimum and the max, I would just, by eyeballing it, would say is about 2,500 RPM to maybe about, maybe 1,000 or so. Oops. And you'll notice here that, You'll notice here as well that the accelerometer, this looks like there's much more jerking back and forth with when the gear shifting is happening. And by the way, I should add that this car does have what is known in America as a millennial anti-theft device, which I believe over here is known as a manual transmission. So let's look at a third driver. This is another trip by driver number two. Again, you see the slope, the same kind of broad range in RPM, and one more. I think this, again, same general thing, making full use of the engine there, but the shift points seem to be a little bit different here. Same kind of activity in the accelerometer there. Looks like there was a hard brake right there, perhaps. And so just to put these up against each other. So clearly, you can see that there are differences in how people drive, and you can see that this does map out to data that the car is actually collecting. The models that I made they were very successful in identifying that I was not driving the car. They were less successful they could identify those anomalies very well, but unfortunately, some of the data that, for my trips, it was significantly less accurate. It was better than chance, but it was still less accurate. I think that's largely a function of the corrupted data that I had, because one of the columns that was unfortunately very inconsistent was the accelerator position, and that was something that I really was hoping to use. So it's still, bottom line is that it's still very much a work in progress, but I believe it's possible, and so I'm going to keep working on that. And it was one of those things where I'd collected data for several months. You just kind of eyeball it to make sure, again, with 600 columns, it's kind of hard to, you don't really know initially what you're looking for. So it's difficult to see. And then, when you start actually digging into it, that's when you find that, halfway through it, you just have nothing but zeros in one column or something like that. So in any event, it's still a work in progress, and hopefully we'll be able to do that. But there's a lot of uses that I could imagine for this data. One of the things that I could see would be very useful would be fuel optimization. Some of the sensors in the car, since the car's fuel consumption is completely regulated and controlled by computer, you know at what rate the car is consuming gas. If you were to combine this with an analysis of a person's normal pattern of life in terms of where they go and where they end, you could figure, and if you were also to pull in the fuel prices, you could optimize, you could basically send the person an alert and say, your best option now that you're below a quarter of a tank of gas is to get off at this, to buy gas at this fuel station rather than the one that's closer to your house where fuel is more expensive. or things like that. And for an individual, that might seem trivial, but if you're operating a fleet of vehicles, that actually could equal some significant savings. Some other things that this data could be used for would be risk management. In America, I don't know if this idea has come overseas or not, but several auto insurance companies have offered their customers devices similar to the automatic that also have their own GSM connection. So you plug this device from the insurance company into your car, and now you're enabling the insurance company to track your driving habits. And in exchange for that, in theory, they give you lower rates. This is a relatively new development. I'm just curious, has that appeared in Europe yet?
Yes.
Okay, so I think we may be lagging behind you a little bit, but I'm very interested in knowing kind of what data the insurers are actually pulling off of vehicles, other than like locations and things like that. Are they actually looking at how a person is driving? Are they trying to figure out individual drivers or not? So in any event. Fraud detection. So this was something that I read an article about and was intrigued by. The Tesla Motor Company, I think about a year ago, they gave a car to the New York Times to do a review about as a way of promoting their supercharger system, which, if you're not familiar with it, it's a system of rapid chargers that they've installed all along major highways in the U.S. And so this auto reviewer for the New York Times basically wrote a fraudulent story claiming that he ran out of energy like halfway between New York and Boston. And so this was the article that the person actually wrote. And essentially he was trying to claim that electric vehicles are not all that they're cracked up to be. However, he did not realize that Tesla had complete vehicle telemetry built into their vehicle and were tracking him the entire time. And they posted this article, which demonstrated conclusively that he did things like did not fuel up the vehicle entirely, drove around in circles, didn't do things that would be, like conducive to him actually getting where he needed to go, and essentially proved that his story was, shall we say, less than accurate. So it was an interesting story, an interesting use of vehicle telematics. There was another story which I heard about where I think it was Toyota, used data similar to this. There were a number of instances in the U.S. where people were claiming their accelerators were stuck on the Toyota Prius, and they used information like this to basically suggest that this was driver error. So what does all this mean? We can figure out everything from someone's life based off of their car. Okay. Realistically, though, while data like this has been collected for the last 20 years, it's only recently that we've been able to get this data off of cars in a way that it can be analyzed. And so ultimately, though, what I think is that consumers, again, do not really understand implications of large-scale, ubiquitous data collection like this. I think people more and more now understand the implications of data that's being collected on the internet, but I don't know that that understanding necessarily translates to things that collect data. And usually, the implications are understood when there is some sort of massive data breach, and that's when people start talking about it, and that's when our Congress starts passing strange laws about these sort of things. But now, there are obvious privacy implications, and there's with data that can be collected from cars. I would argue that this is probably some of the most sensitive data that could be collected. Imagine if you're like, say, a law enforcement official, and your vehicle has some sort of tracking. If that were exposed to the world somehow, then your activities and your investigations might also be compromised, and so that could be potentially very dangerous. I see this kind of data collection ultimately as a social contract that is based between consumers and data collectors, and that if companies are going to be doing this sort of thing, if they're going to be collecting this frankly very invasive data, there really should be some sort of mutual benefit for the consumer. And a great example of that is the Waze app. I'm pretty sure, Waze exists in Europe? Yeah. So if you're not familiar with Waze, it's a mapping application, but its unique feature is that it uses your locational information as well as that of others around you to identify traffic patterns and find you the optimal route to your destination. And oftentimes it can send you on these crazy roundabout ways of getting there, but it bypasses, you can avoid a lot of traffic that way. And again, it is able to do this because it is gathering your information and those of other people to figure out what the traffic patterns are. And so, in closing, I hope that this talk will give you some food for thought about the kinds of data that vehicles collect and the different kinds of things that can be done with it, and just also what are the broader implications of having these massive data collection devices in your driveway. And so with that, are there any questions?
All right. So just quickly, just say thank you, Charles, for the great talk. So just a quick round of applause. And I think we've got time for probably one or two quick questions, and then we'll give you time to move between rooms. So anyone for a question with Charles? Gentleman there?
Just the use cases where this sensor data, the car owns, has been shared for the car maintenance companies, so that they can invite you for their regular release or something like that.
Are you asking, has it been done? Oh, so the question is, has this kind of telematic information been used for vehicle maintenance? I'm not aware that it has been yet for vehicles. I know that for larger applications, such as like heavy equipment, jet engines, and things like that, those kinds of that kind of equipment have sensors that can detect when it is in need of maintenance. And I know that General Electric and probably Rolls-Royce, they have been able in the last, I don't know, since they started doing it, to refine their maintenance schedules and replacement schedules. So before, they would just kind of set some arbitrary number, like you have to replace this part after 10,000 hours. Now they're able to identify when parts are more likely to break with a much greater degree of accuracy, and not just set arbitrary numbers like that for maintenance. So yes, in heavier equipment, not so much in smaller equipment yet.
Maybe one more? The back, yeah.
Just to elaborate on that, it is actually being used for that on existing vehicles.
Okay, any last questions? Otherwise, just say thanks again to Charles. The next talk in here is going to be on Kafka with Gwen from Confluent and Jeff from Cloudera, and that will start at 12:05. Okay.